absolute value. Okay, makes that V shape. Whatever you put in turns out positive. Absolute value is distance from 0. You can't have a negative distance, that's why absolute value turns everything positive. Okay. The first thing I'm going to do, we know we've been working with transformations in the absolute value graph. We know it gives us that V shape. You can also apply absolute values to different equations. So I'm going to give you an equation. We're going to graph it using transformations, and then we're going to do the absolute value from the graph. So here's our problem. I want to give the domain and range of these two things. To find domain and range, it might be easiest to look at a graph. The graph of x squared is a parabola. What would your transformation be here? Go right 4 and down 3. Okay, so I get that graph. Could you give me the domain and range of that function? Range? This.
No, you got -2.
Okay. Alright, is that part okay? Now I want the absolute value of that. I'm going to do mine on the same graph. I'm just going to switch colors. Absolute value, if it's positive, does it change it? No. So the positive portions of my graph would stay. But what happens with all your negatives? They turn positive. So this point, 4, -3 is going to go to 4, +3. I had 5, -2, so that's going to go to 5, +2. I had 3, -2, so that would go to 3, +2. What this graph does, the positive parts stay the same. The negatives get flipped. And so my absolute value looks like that. It just took the negative parts of the graph and flipped it up. Okay. Did I confuse you by doing it on the same graph?
No.
If you need to draw them separately, you can. You're just basically taking your points and any y values you make them positive. Okay, I'm going to do another one here in a second, and I will draw that one separately for you. What's the domain of this one? Yeah, it's still negative infinity to infinity. The domain is not going to change by doing this, but my range, you can't have negatives if it's an absolute value. So my range becomes 0 to infinity. That's going to be the only difference. If I wanted to give the domain and range of this original, what would your domain be? What's the range of that? Okay. You could draw them on the same graph if, that is crooked. if you drew them separately. That's not much better. Alright, the 0.30, is that going to move? No. The 6.3 isn't going to change because these already have positive values. So that part remains unchanged. It's this red portion of my graph here. Those had negative values. So those change. 0, negative 2 is going to go to 0, positive 2. So you'll have a horizontal line going this way. We have the 0.1, negative 3, so it's going to go to 1, positive 3. So it just takes this pink portion of the graph here, and when I say the absolute value of it, it can't be negative, so you have to move that part above the x-axis. It's like making the y values positive on that part of the graph. What's the domain of this? The domain shouldn't change, but my range did. What's my new range? 0 to infinity, because you can't have negatives with an absolute value. I'm going to give you guys one. You're going to draw the function, give domain and range, and do the absolute value and give the domain and range. So I want you to graph both of these, give the domain and range each. Two x minus 1, what's the graph of that? Line. Y-intercept negative 1, slope 2. Okay, so this one, when you did the absolute value of it, the positive part stays the same, but the negatives part flips. So 0, negative 1 is going to go to 0, positive 1. This positive part remained unchanged, but this flipped up, so you get this absolute value graph here. Domain of the original? Range? Domain of the new? Questions?
Okay, so when you're doing the absolute value graph, I don't exactly get how to do it. Is it just
Okay, if you took points here, so this is like 0, negative 1. This would be the point negative 1, negative, should be a negative 3. My graph's a little off. When you do the absolute value, it's making these y's positive. So instead of 0, negative 1, it's going to be 0, positive. Negative 1, negative 3 will go to negative 1, positive 3. So it's just making the y portion. Other questions? That was the only new piece. The rest of this is going to be review. In Algebra 2, you solved absolute value equations and inequalities. So let's talk about the options. If I said the absolute value of x equals a number, what are your options for x?
0.
Okay. If I said absolute value of x equals 4, what was my x? 4 or negative 4. So if I give you an equation, you make two separate ones. The first one, you just drop the absolute values. Second one, you drop the absolute values and set it equal to a negative. Because since absolute value turns everything positive, it could have originally been a positive or a negative.
So are we gonna
less than, a less than is an and. If you have a less than, you make one big inequality and you put it in between the positive and the negative. A less than is an and statement, so you make a compound inequality and solve it. Great or than is an or, so you do two separate ones. Greater than the positive or less than the negative. So I would write these three things down. That's what we're going to be using to solve the rest of the problems today. If it's an equal to, he said equal to positive and negative. If it's a less than, that's and, so you make one big inequality. If it's greater than, that's or, so you do two separate ones and solve from there. The key to all of these is you have to first make sure you have isolated the absolute value. It only works if the absolute value is by itself when you begin. Okay, so the first one here. What am I going to do?
Solve for
Two equations. First one, you drop the absolute value, change nothing else. The second one, you drop the absolute value and set it equal to a negative sign. So we're just going to solve each of these. So if I subtract 1, divide by 2, I get 3. Over here, if I subtract 1, divide by 2, we get negative 4. Can you check these answers? Absolutely. Plug negative 4 in, you get negative 8 plus 1 is negative 7, absolute value is positive 7. Plug a 3 in, absolute value 7 is 7. B, what do I need to do? I have an issue because of this negative 3. We need to get the absolute value by itself, so we'll first divide everything by negative 3. So then I have my absolute value is equal to 5. Now, do your two equations. And so if I subtract my 5, divide by 4, here if we subtract 5, divide by 4. So we get 0 and negative 5 halves. Are we doing okay with these? Do we need more? You understand it after 2 examples? Okay. Let's talk about some inequalities. So, first step is to make sure the absolute value is by itself, which on part A it is. Second step is to decide, is this an and or an or? Great or, this is or. So you do two inequalities. The first one, just drop the absolute value. For the second one, you flip the inequality and make it a negative. divide by 2, so a is greater than or equal to 6. This one, if you add your 4, divide by 2. I want the interval notation here, so if you need to, you could draw yourself just a rough graph. Greater than or equal to 6 would be starting at 6 and going to the right. Less than or equal to -2 would be starting at -2 and going to the left. So if I ask for the interval notation, what would you write for the first piece? Union, this piece. How do you know if you need a bracket or a parenthesis? Right, it has the equal to, that's a bracket.
So it's,
No.
so you expect us to do both of them in the same thing without trying to confuse ourselves?
Yep.
No, I'm missing.
You
That's-
solve the inequalities like normal. Your answer is an interval. So at the end, then it's just like when we first learned interval notation, you were solving inequalities and writing it as an interval, so we're still going to do that. Other questions? B, what do I need to do? It's a less than, but before I get to that part, what should we do? Subtract the 6 first. Get the inequality or the absolute value by itself. So if you subtract 6, you get this. Then it's less than, which is and. So and says we were going to make one big inequality. You put another less than and the negative on the other side. So you stick in between the positive and the negative. It's a compound inequality. -6 is less than 3b minus 1 is less than 6. Okay, what do we do?
Add one to both sides.
So that would give me -5 is less than 3b is less than 7. Divide by 3. Okay. Your final answer is the interval. If you need to, you can draw yourself a little sketch. Okay, -5/3, that's like -1 2/3. 7/3 is 2 1/3. You're just talking about in between those. When it's an or statement, you get two separate pieces. With it's an and statement, you should just be getting one interval for the end. It's just in between those two values. So greater than is an or, you are going to get two separate pieces. Less than is an and, you have one piece just in between the two. Questions? How much of this do you remember?
I remember everything except like doing like the union and the graph part.
The new part, you did everything except the way we're writing our final answer in Algebra 2. We graphed them, we wrote the inequalities, we just didn't write the intervals in Algebra 2. Alright, I've got some more. Do we need more?
No, we're good.
Okay. Let's do one more like this, and then I've got just a couple other things that I want to mention. Okay? On C, what do I need to do first?
Get the, or divided by -5 on one side,
Before that,
subtract 2.
subtract our 3 first. So that's -19. Now divide by -5. When you divide by a negative, what happens? Okay. So, and or? And, so you make your one compound inequality. 2 from everything. So negative 19/5 minus 2. Positive 19/5 minus 2. How are we going to write the final answer? You can draw a graph if you need to, or you can recognize that it's an and, you're going to get that one piece at the end.
So you don't have to draw the interval.
The interval is just if you need help.
Alright.
Is that okay? Let me ask you a few questions. Part A. The absolute value of 3x plus 5 equals negative 5. Just solving it? Does anybody notice anything weird about this?
It's not possible that it's negative.
Yeah.
Can absolute value equal a negative? No. You could solve it, and then if you check your answers, they won't work. What I would recommend is anytime you have the absolute value by itself and it's a negative here, stop and think. This one is going to be no solution. Absolute value can't equal a negative. B. This is saying the absolute value is less than a negative. Can an absolute value be smaller than a negative? No. Absolute values are positives. A positive is never smaller than a negative.
You can't do that.
Yeah, see, we can. Absolute value bigger than a negative. Absolute values are positive. When is a positive bigger than a negative? Always. So this one is negative infinity to positive infinity. These are problems where you can still work them out and solve them.
We don't want to do that.
But if you recognize once you get the absolute value by itself, if you have a negative, it's either going to be no solution or negative infinity to positive infinity. Just stop and think which one. Alright, is that okay? Last thing I want to mention, last example. I've got 2 up here, but we only need to do one of them if you understand. This is an absolute value equation, but I have absolute values on both sides. However, that's not going to change anything. We're going to treat it just like we do all the other equations. So when we have an absolute value equation, we do 2 of them. The first one, we just drop all the absolute values. The second one, you drop the absolute values and we made it a negative. What you have to do is make an entire side negative. So you'll have to distribute that negative. And then those would be the 2 equations you solve. So if I subtract my x over, add my 3, get 9. Here, if we distribute, add my 2x, subtract my 6, and we get negative 1. Okay, so if absolute values are on both sides, drop them for the first one. Second one, distribute a negative through one side.